Welcome to the Mathematics in my channel. Today we are going to solve another interesting integral. Integral from 0 to 1 natural log of gamma of x over gamma square of x over 2 times cosine of phi x dx. Well, how to begin? Okay, first we know the King's property. 0 to a f of x dx is equal to 0 to a f of a minus x dx. Now we can apply King's property for this integral. So we can write now this is equal to I is equal to integral from 0 to 1 natural log of here gamma of 1 minus x over gamma square of 1 minus x over 2 times here cosine of, we know cosine of pi minus pi x. So cosine of pi minus pi x, we know, minus cosine of pi x. So here minus cosine of pi x dx. Okay, now I am going to take sum of this two equation. So we can write now 2 times I is equal to integral from 0 to 1. Now we know cosine of pi x is a common factor, so cosine of pi x, and here natural log of gamma of x over gamma square of x over 2, and here minus, so minus natural log of now gamma of 1 minus x over gamma square of 1 minus x over 2 here dx. Okay, now we can simplify. Now 2 times I is equal to integral from 0 to 1 cosine of pi x times, here we know according to property of natural log, we know natural log of a minus natural log of b is equal to natural log of a over b. So now we can apply this property. So here we can write now natural log of gamma of x over gamma square of x over 2, then we should divide by this part. So now here in the denominator, gamma square of 1 minus x over 2, here gamma of 1 minus x here dx. Okay, now what can we do? Okay, now we know the duplication formula for gamma function. So what is the formula? We know gamma of c times gamma of c plus 1 half is equal to 2 raised to the 1 minus 2 times c square root of pi times gamma of 2 times c. Okay, in a previous video we proved this duplication formula. If you like to watch that video, I will add the link in the description and also make a card. Okay, now our question, 2 times I is equal to integral from 0 to 1 here cosine of pi x times now natural log of, now here instead of gamma of x we can substitute by this equation. So to take gamma of x we can plug in instead of c we can write instead of c we can write x over 2. So we can write now here here gamma square of 1 minus x over 2 I rewrite. So gamma square of 1 minus x over 2. Now instead of gamma of x we can write here gamma of x over 2, gamma of x over 2, then here gamma of x over 2 1 half gamma of x over 2 plus 1 half, then we should divide by 2 to the 1 minus 2 to the 1 minus 2 times. Now c is equal to x over 2, so 2 get cancelled, so 1 minus x, and then square root of pi, okay, then we should rewrite gamma of 1 minus x by using this formula. So we can write here here gamma square of x over 2 I rewrite gamma square of x over 2. Now instead of gamma of 1 minus x, now we can plug in instead of c we can plug in to get gamma of 1 minus x, gamma of 1 minus x we can plug in 1 minus x over 2, 1 minus x over 2. So we can write now here gamma of c, so gamma of 1 minus x over 2 times now c plus 1 half. So we can write now gamma of, instead of c we plugged 1 minus x over 2, so 1 minus x over 2 plus 1 half, then we should divide it by 2 raised to the 1 minus 2 times c, so 2 times c is equal to 1 minus x over 2, so 1 minus x, then square root of pi, okay, then here dx. Okay, now we can simplify, so then we can write integral from 0 to 1 cosine of pi x, here natural log of, now we know the square root of pi get cancelled, also gamma of x over 2 get cancelled, also gamma of 1 minus x over 2 get cancelled, and now we have here 2 raised to the 1 minus x, here 2 raised to the 1 minus x, so we can write if we simplify this we know 2 raised to the x, 2x, or 2x minus 1, 2x minus 1, then here gamma of 1 plus x over 2, here gamma of 1 minus x over 2, so gamma of x plus 1 over 2, gamma of 1 minus x over 2 over, now here we have gamma of x over 2, gamma of x over 2 times gamma of here 1 half we know 1, so 1 minus x over 2, gamma of 1 minus x over 2 here dx. Okay, then next step we can write 2 times I is equal to integral from 0 to 1 cosine of pi x natural log of, now we know here 2 raised to the 2x minus 1, then 2 raised to the 2x minus 1, then here gamma of x plus 1 over 2, gamma of 1 minus x over 2, so I am going to write gamma of 1 plus x over 2 times gamma of 1 minus 1 plus x over 2. Okay, I arrange this part because I'm going to use Euler's reflection formula. Okay, then here in the denominator we will have gamma of x over 2, gamma of 1 minus x over 2, here dx. Okay, now we know Euler's reflection formula. So what is the Euler's reflection formula? We know gamma of x times gamma of 1 minus x is equal to pi over sine of pi x. Okay, now we can plug in. So 2 times I is equal to integral from 0 to 1. Now cosine of pi x, here natural log of 2 raised to the 2x minus 1. And now instead of this term we can use Euler's reflection formula. Also this part we can use Euler's reflection formula. So for this part we know this is equal to pi over sine of sine of 5 over 2 plus 5x over 2. So pi over 2 plus 5x over 2 times, now instead of this part we can write here pi over sine of now pi x over 2, here dx. Sorry. Okay, then we know this pi get cancelled, and here sine of pi over 2 plus pi x over 2, we know this is equal to cosine of pi x over 2, and sine of pi x over 2 over cosine of pi x over 2, we know tan of pi x over 2. So now we can write 2 times I is equal to 2 times I is equal to integral from 0 to 1. Now we can simplify natural log 2 raised to the 2x minus 1. We know here cosine of pi x, and here we can write now 2x minus 1 times natural log of 2. Now according to property of natural log, here multiplication to be plus, then natural log of, we know this is equal to tan of pi x over 2, here dx. Okay, then I is equal to, we know here 2, so 1/2 integral from 0 to 1. Now we can simplify. So here natural log of 2 also constant, so here natural log of 2 over 2, and here we know 2 times, again 2 is a constant, so x times cosine of pi x dx, and then here plus now natural log of 2 minus natural log of 2 times cosine of phi x, so here minus sign, here 1/2, so 1/2 natural log of 2 integral from 0 to 1 cosine of phi x dx, and then here we have cosine of pi x So plus 1/2 integral from 0 to 1 cosine of pi x natural log of tan of pi x over 2 dx. Okay, then we can simplify this 2, get cancelled, and here we have x times cosine of pi x dx. So I am going to take this integral is equal to j1, and here cosine of pi x, we know sine of pi x over pi from 0 to 1, so this is going to be 0, and this integral I am going to take j2. Okay, now we are going to evaluate j1 and j2. So we know j1 is equal to, j1 is equal to integral from 0 to 1 x times cosine of pi x dx. So I am going to rewrite x. Now I am going to integrate by parts, and here d by dx. Now integration of cosine of pi x, we know sine of pi x over pi here dx. Then we can write this is equal to product of this two function and integral from 0 to 1. So we know sine of pi x, if we plugged 1 and 0, we know 0. So 0 minus integral from 0 to 1. Now here 1 over pi is a constant, and sine of pi x, derivative of x, we know 1. So here dx. Now we know this is equal to minus 1 over pi. Now cosine of pi x over pi, so minus cosine of pi x over pi, integral from 0 to 1. Now we can write this is equal to, we know, minus 2 over pi square. Okay, then I'm going to evaluate j2. So now we know j2 is equal to cosine of pi x, natural log of tan of pi x over 2. Again we can use integration by parts method. So we can write now integral from 0 to 1. Now I am going to take natural log of tan of pi x over 2 as a first function, as a u, and then d by dx, then d by dx, we know integration of second function, so sine of pi x over pi dx. Okay, then we know product of these two function, so natural log of tan of pi x over 2 times sine of pi x over pi, integral from 0 to 1, minus 1 over pi is a constant, and here sine of pi x. So instead of sine of pi x, I am going to write 2 times sine of pi x over 2 cosine of pi x over 2, and then derivative of natural log of tan. So we know 1 over tan of pi x over 2 secant square of, according to chain rule, secant square of pi x over 2 dx. Okay, then we can simplify. We know now this is equal to 0, and here pi minus 1 over pi, here sorry, we should multiply by pi over 2, and this pi get cancelled, and here we have minus 1 over 2. Now we know sine of pi x over 2, here secant square, so cosine of pi x over 2 get cancelled, and sine of pi x over 2 over secant 5x over 2, 1 over cosine of 5x over 2, and we know get cancelled. And here we have now minus 1/2, here 2, also this 2 also get cancelled, and here we have x from 0 to 1, and if we simplify, this is equal to minus 1. Okay, now we know I is equal to here natural log of 2 times j1, then plus here 1/2 times j2. Okay, now we know here j1, we evaluated j1 minus 2 over 5 square, so minus 2 natural log of 2 over 5 square, here plus 1/2 j2 is equal to minus 1. So this is equal to minus 2 natural log of 2 over 5 square minus 1 over 2. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.